Hi everyone, welcome to my channel. Today we will be discussing important features of Java 8. There was a lot of good additions in Java 8 version and the topics are really important for Java interviews as well as your course materials or any kind of exams. So be with me till end of this video. We will discuss each features in detail. Uh, that we had from Java 8 is Lambda expression, stream APIs, optional classes, default methods in interfaces, date and time API. So these five were the main additions in Java 8, and these are really important. If I talk about Lambda expression or streams APIs, right? These are hot questions for your interviews or any kind of exam. So let me discuss each of them in detail. I'll just open the section. Let's suppose Lambda expression, right? So there it was added as a method, and basically there is a concept called functional programming. It enables functional programming in Java. There are a lot of predefined functions that are available in Java, so we'll be discussing that as well. Now there is no particular definition that anybody is going to ask you, but understanding how they work is really important. So there are different ways actually that you can declare this method or how to use it actually. So the key concept is parameter, arrow, operator, and body. So as you can see in the screen, this is the uh, actually the syntax for the lambda expression. There are parameters, there is expressions, then there is combination of these actually, right? There are different ways to implement the lambda expressions. So the first one is using single expression. For single line operations like this, you don't need any braces kind of stuff. You can simply just perform your operation and it will automatically return the value, right? You don't need to define the data types as well. It will automatically get it, right? Now using code block, so this is another way you can declare it, where you have some statements that is wrapped inside a braces like this. So you have this is input to the lambda expression, and then obviously you have this body, right? So this way you can declare, and at the end you will basically return it, whatever is your method or logic is. There is no parameters. Okay, this is also a lambda expression. You are simply doing printing any statement kind of stuff, right? So the fourth way is actually single parameter, no parenthesis, like this is also a valid one. Okay, with parameter type declaration, where you provide the data types, right? So this is perfectly valid, but if you remove one of the data types and provide data types for others, uh, that will not be valid one. So if you remove this int basically, and if you try to give data type for b only, that will not be correct syntax, right? So if you're providing data types, provide for both. If you're not providing for none, right? So this way. Now lambda expression is used with the functional interfaces, and these are the general in functional interfaces that we have. There is a runnable, callable, comparator, predicate, and the function itself, right? With each of the examples, so runnable, basically how you can utilize it. I've tried to separate the uh, two ways. One is how you can traditional way of calling it, and the another way is using the lambda expression, so that you understand the differences, right? This is not complete, this is kind of a pseudo code, I would say, a snippet, not the complete code. So runnable, this is how in tradition methods you will do, right? Using the lambda expression, you simply create reference to the runnable and then simply call out the lambda expression, right? Since you are not taking an input, you are simply just printing in a statement, so you do it. Then using the task lambda, you will run the methods from the runnable class, that is run, right? You can call it using that reference and you will get the input, I mean output, right? That way. Now the comparator interface, similar how earlier you used to um, compare the two values using the comparator, right, from the list. So this was the traditional approach, where you write a lot of code, 3 4 lines, and you override the compare method, right, in order to compare the two objects, right? Now using lambda expression, it is easy, single line, you can easily do it in this way, right? You take the input and basically calling the same methods in the single line itself. So this was the lambda expression, how it is helping, you can clearly see. you are writing less code and it is more understandable actually for a smaller logics. Now lambda expression you can use with the collection as well, right? So there are different collections where you can use the lambda expression. Let's suppose we have the list here, right? Now traditional approach, how you will print the elements like this way. Here we are trying to basically find if it is divisible by 2 or not, right? If it divisible by 2, then only we are writing. So we are writing this for loop, then if condition, then we are getting the result. But using the stream apis and lambda expression, you can do it easily. So as of now, if you don't know the stream apis or you don't have much idea, totally fine. Here you only have to understand how we are using combination of these two features to make it more efficient. So this stream we are calling on numbers list, then it is basically giving us the stream, then applying the filter method, and we are checking whether using the lambda expression we are checking if it's divisible by 2 or not, and then if it's divisible, then we are simply using another uh, method basically to print it, right? This way, using the stream apis you can do it. This is easy way. Method references with lambda expression, this is another concept actually. So lambda expression can sometimes be replaced with method references, providing an even more concise syntax, right? So this is like you have declared a list, then using lambda expression you can simply see you're simply just calling um, over it, over the names of list, and then you are trying to print it, right? And using the method references, this is another way where you simply, instead of writing println and all, you are simply doing println, it will do the same thing, right? So this is how you do using lambda, using the method references, where you put two colon and then you get the reference. This is what we are calling a method reference, right? Now custom functional interfaces, how can you create your own functional interfaces? So if you don't understand what is functional interfaces, let me tell you. So the interface which has the single abstract method is known as the functional interface. So you know, any method that is declared inside the interface is by default abstract, whether you are using the keyword or not. So this is abstract method. Now for better understanding, we are using functional interface annotation, which basically forces the behavior of functional interface, right? Then a simple class, we are using it, creating an reference to the interface math operation here, you can see. And then we are trying to add basically two values by passing this way. And the another we are trying to show here is multiplication. So using lambda expression, then multiplying two values, right? Now using these references, we are trying to call it over the method that is operate. Now you see addition dot operate or the multiplication dot operate. So the addition dot operate will return you the addition of 5 and 3. The multiplication will return you 5 and multiplication of 5 and 3. So this way, this is a really important question for interviews of any company or exams also, right? How you create your custom functional interface. Can you show, can you using the functional interface, can you add two numbers? They will ask you to do something like this, right? So you can show them how you are creating an interface. It will have a single method, right? And then you are calling it using reference, and the same will work. Now basic things you should understand. Nobody is going to ask you, I believe. Sometimes they ask you, right, how lambda expression is better from other methods, why it is important, kind of stuff. But yeah, so concise goes for smaller logics actually, right? Eliminates the need of anonymous classes, which is sometimes very complex. Improved readability, as I said earlier. Encourages functional programming, right? We have seen quite a lot um, of function that we are trying to use, right? It works well with the stream apis as well. So there is a improved performance kind of stuff that is attached to the same lambda expression, right? Limitations with, like, you should not go for a complex logic because sometimes it's really hard to understand when you have a large base of code, right? So for smaller logics you should prefer lambda, but not for the larger ones. These are the limitations, I would say. In this you can also find comparing the lambda with the anonymous classes, right? So the syntax concise and verbose. Target type functional interface only. Any interface or abstract classes you can use the anonymous class, right? Then some of the other use cases, readability, overhead kind of stuff, right? Single abstract method interfaces use cases, complex multiple method interface actually. Then best practices, some of these are some of the theoretical concept actually. Now next part is stream API, so we'll be discussing stream APIs in next video. All the best.